Okay. So, well, good morning, everybody, and welcome to our regular Thursday Scarecrow MBSE Embassy. And this week we're going to be talking about understanding and model-based systems engineering. Hopefully you can all see my screen. Otherwise, it's not going to be much of a presentation, to be honest. For those of you that haven't met us before, my name is John. I'm this one here, and Simon.
And I'm that one there.
That one there.
Yeah, so, I don't have a body. I'm just like a big disembodied head that floats around.
Yeah, he's like that. Oh no, it's too obscure a science fiction reference. I won't do it. So I'll be leading today, and then Simon will be coming in and giving his opinion at various points throughout the presentation. We would say we've actually got a protocol slide this week. So basically, as a default, you're welcome to say things, but as a default, unless you've got something to say, please mute your microphone just to cut down on the background noise. If you've got any questions, just put a note in the chat and we'll pick up on it, and we'll invite you in to either ask it or we'll answer it outright, depending on how much you've written in your question. After we finish the presentation, there's a number of resources available offline. There will be the slides with the hand-drawn notes on that we'll be doing throughout the presentation. We are recording this, so there will be the video of this available as well. You'll get access to the Scarecrow's knowledge base, the Scarecrow's knob, should you want to, that contains all sorts of source information, information on patterns, profiles, all sorts of stuff in there.
And also, John, that's where we're actually putting the slides with the notes as well. We're putting.
Oh, okay, the slides.
Yeah, the videos will be on the YouTube channel, and the slides will be on the knowledge base.
Oh, great. Okay. And so, as usual, you just have to go on our website and click on Scarecrow's knob and send us an email, basically, and we'll give you access to the knowledge base. I believe it's not as secret as it once was.
No, I believe it's actually been indexed by Google.
Oh, right. Okay. So we've now, yeah, there we go. So today we're going to be talking about understanding, basically. And this is a slide that we've had for the last few weeks. So we're really continuing the theme that we've had the last few weeks, which is really to say, when it comes to systems engineering, we need systems engineering, as it's very, very easy for things to go wrong in real life. And you have to remember that when we're talking about systems engineering, we're talking about real life systems engineering. We're talking about applying systems engineering to help us realize successful systems. And that's what we've always got to remember at the back of our minds. And particularly when we talk about things like model-based systems engineering, we have to remember it is very easy to get carried away and to forget the original goal. So the goal is to deliver the system successfully. When we talk about MBSE, we're going to be doing that using models. And today we're going to be talking about the concept of understanding in models. And the reason for that is when you look at why things go wrong in real life, there are many books and papers and so on investigating disasters and system failures and project failures. But fundamentally, there's three underlying reasons why things go wrong that we refer to as the three evils of systems engineering. And these are complexity, communication, and a lack of understanding. And today we're going to be talking about this understanding and some of the ways that we can actually increase our levels of understanding. Complexity and communication we've covered in the previous two presentations that we've made. So if you want to know more about those, please just access our either the YouTube channel or the knowledge base, and you'll find the information regarding that. So when it comes to understanding, like many things in systems engineering, we do have to state the obvious. It's crucial that we can understand the system. We have to bear in mind that when we're talking about model-based systems engineering, the model from model-based systems engineering is the entity, it's the single source of truth, and it's the thing that contains and very importantly owns all our data, all our information, and all our knowledge. If we want to know anything regarding the system, we interrogate the model, and that lies at the heart of model-based systems engineering. So rather than all the knowledge and information and data living in the documents, which we get in a traditional document-based approach, When we talk about model-based systems engineering, this not only resides in, but is owned by model. And that's the first thing that we need to understand. Because of that, it's very important that we've got a good understanding of everything that goes into the model. Now, what we have to remember is that we can't possibly model everything. We can't possibly try and understand everything, because there's just too much information out there. We have to remember that a model is an abstraction of something, and as it's an abstraction, as it's a representation of something, there will be information missing. When you speak to some people, and I'm trying to be polite here, but we do come across them all the time, but people who are not the biggest advocates of MBSE, they will always say all models are wrong. Okay, this is a nonsense thing to say. And, you know, people say all models are wrong because they're incomplete, therefore they can't be right. Okay, this is a nonsense thing to say, and it's a fatuous argument. The model is not intended to contain every single bit of information. It never has. A model that has every single bit of information in it is the actual system. Okay, it's not an abstraction. The model is an abstraction of the system. What we need to make sure is that the model contains enough information, enough data, enough knowledge in order to deliver a successful system. Or to put it another way, it needs to contain enough data, information and knowledge in order for us to perform our systems engineering. And that's what's key to doing this. The goal of creating a model is not to squeeze in as much information as possible. The goal is to have enough information to allow us to deliver the system, to allow us to do our jobs properly. So when you come across people that say all models are wrong, you can quite safely just ignore them, to be honest. They're not worthy of your attention. So when it comes to understanding and systems engineering, this is one of the sort of cornerstones of systems engineering. We have to go across the entire life cycle. And this is one of the distinguishing features that we have in systems engineering. It's one of its main attributes, is we apply our systems engineering across the whole life cycle. It is important to get things right at the beginning when we are in the conception stage, when we're looking at things like needs, when we're looking at requirements and so on. But the problem that we have is many people put all the effort into the conception stage, into understanding the needs, and then seem to forget about the rest of the life cycle. So yes, it is important that we can understand our needs, but it's also important that we can go beyond this, and we can go beyond things like design as well, because another myth is that, well, our modeling, our understanding stops. Well, people will say we don't need to model after we've done our design. That's like saying we don't need to understand anything after we do our design. Of course we do. We must understand the entire life cycle from conception to retirement, depending on the life cycle model that you're following. So we must cover the entire life cycle, but also, very importantly, we must cover all relevant points of view. And this is where the main discussion is going to be this morning. What we must understand is that whenever we model something, even if we don't realize it, we are modeling something from a specific point of view, whether that's based on a stakeholder, whether it's based on where we sit in the system hierarchy or whatever. All these different points of view exist. We're going to look at both of these this morning, the stakeholder point of view and the different points in the hierarchy point of view. When we look at something from a specific point of view, when we look at something with a specific bias, if you like, from a specific point of view, we call this a context. So when we talk about context modeling, we're talking about modeling from a specific point of view. Whenever we model anything, we are always applying a context, even if we don't realize it at the time.
John, before you carry on, we've had a question from Mital saying any framework or methodology to capture life cycle in SysML would be appreciated.
Okay. Now I'll answer that very quickly now, and if you want, we can make that the subject of another presentation. Yeah. Because we could easily have a whole presentation on that. Yeah. Life cycles is very important. I'll just answer very, very briefly now. Life cycles are very important, and it's one of the areas that's way, way more complex than people think it is. People often think, oh, life cycle, they'll think of waterfall or whatever, or even acquisition life cycles such as CAD/MID or whatever. People confuse different types of life cycle. People don't realize that life cycles interact with one another, and people don't understand the difference between life cycles and processes. The simple answer is if we want to understand our life cycles, it's a very good example of modelling. We can apply our modelling to understand them. Yes, let's make that the subject of another presentation, Simon. Can you make a note on that?
Yeah, will do. Yeah.
So who was that question from?
Mittal.
Okay, all right. We'll make that the subject of another presentation, Mittal, especially for you. We'll dedicate it to you, Mittal. Okay, how's that?
Thank you very much.
That's okay. Anytime. We're here to please, in most cases. So back to today then. When we talk about a context allows us to look at something from a specific point of view, and that's very, very important. We've got to remember that a model is actually made up of different views. Whenever we create a view, whether we're realizing it or not, we are modeling that from a particular point of view, whether it's from our own personal point of view, from the point of view of a different, from a user or an operator or whatever. And when we talk about views, we're not just talking about diagrams, but also text. As soon as we start to write some text to describe something, we're putting our own bias on it. We're giving it its own context. Mathematics, physical models, any aspect of the model, whenever we create it, any view, we do actually give it a context, whether we realize it or not. Sometimes half of the battle is just identifying what that context is. And we'll look at some examples of that in a moment. There are lots of contexts, such as stakeholders, systems, life cycle stages, processes, and so on. And we will be mentioning these as we go through. But to begin with, let's focus on, let's imagine the context of looking at a few needs. And let's just consider a very simple example. What about a passenger airline? Okay. So let's think at a very, very high level. What are our needs for a passenger airline? So you said, well, obviously it's to get from one location to another. I'd like to be able to save money as well, and also it would be a good idea if the aircraft, for example, was efficient. Now, I appreciate these are very, very high level statements, and if I were to say to people, do you understand when we think about a passenger airline getting to a location, saving money and being efficient? Almost everybody would say yes, they understand that. However, it's not good enough just to then say, okay, we therefore understand all of these needs because everybody agrees that they understand them. What we need to get to the bottom of is, do they understand them in the same way? Are the different stakeholders interpreting the same statements in different ways? Because you can bet that they are, because different stakeholders will look at the same information and interpret it in different ways. And when it comes to modeling, we're not going to, the point of this presentation is not to do use case modeling. We will be talking about use cases, but when we talk about a use case, what it is, it's an interpretation of a need from a specific point of view. And that's the difference between a use case and a need, or a requirement, if you like. It's looking at something but giving it a context. So a use case is describing a need via a context, and that's what we have to understand. Use cases are context dependent, needs aren't necessarily. So let's look at what we mean by a stakeholder. So we define the stakeholder as the role of any person, of any organization, of anything that has an interest in our system. Okay, and obviously we can have multiple stakeholders for particular systems. Okay, somebody's just put up a reference. Stephen's just put up a reference to the all models are wrong. Some are more useful than others. Just a final note on that. The trouble is that when people quote that to you, they very rarely put on the second part of that quote. They just stick with the all models are wrong part of the quote. But there we go.
Yeah, I mean, your point, John. I mean, if I say, all documents are wrong, it's exactly the same thing. No document of a system has the entirety of the system in it. It's, which is again why it's such a specious argument. It's
the only quote I do agree with is the quote, all quotes are wrong, which I've just made up now. So reference that, Stephen, stick that in your thesis. So let's look at different types of stakeholders that we might have. So what I'm going to do, I'm just going to expand on this diagram here and look at these different types of stakeholder that we have. Wherever possible in all these presentations and with everything that we do at Scarecrow, we do try and relate everything back to best practice. So these different high-level classifications of stakeholders are taken from ISO standards. So for example, if you look at ISO 15288, you will see customer stakeholders, you will see external stakeholders, you will see supplier stakeholders. So this is where the language comes from. When we talk about supplier stakeholders, we're generally talking about us, if you like, the roles of the people, the things, the organisational units and so on that are helping to deliver the system. So typically things like engineers and things like managers, so engineering roles and managerial roles. If we go to the other side of the diagram and we look at things like customer roles, then we will have end users of the system, we will have operators of the system that make the system function on a day-to-day basis. We will have the sponsors of the system who are actually paying for the system and putting up the money for the system, if you like. And in the middle there, we've got external, and these are things like laws and standards. Now, the way to differentiate between these two here, between customer and external, if we think of supplier as us, we can think of these two as the them, but the big difference between these two is it's far easier to reach a compromise with a customer than it is with an external. If you don't comply with all your customers' requirements, you can generally talk to them and say, look, let's find a middle ground. Let's find a solution that suits everybody. If you don't comply with the law, for example, it's a lot more difficult to have a non-compliance with law and to get around it somehow. It's not to say it's impossible, but it's certainly a lot more difficult and can be a lot more costly in terms of time and money and so on. So what we have here basically is a set of generic different stakeholders. And the point we want to make here is that potentially each one of these stakeholders that we have on this diagram will have a different point of view. They can look at the same piece of information and they can interpret it in a different way because they've got a different context. Okay, so let's take one of our previous statements that we had, our previous needs statements. So we've got the one to save money, and let's look at this from the point of view of the user. So this is what we call a user context. So the box here is telling me it's a context. This thing here, user context, is telling me from which point of view this information is modeled from. So this is saying, well, you know, here's our basic needs statement. I want to save money. But from the point of view of, let's say, me as the user, this means I want to have a good service from the operator. This is a dated slide now because I no longer smoke. I'm no longer a monster. But for the sake of the example here, I want to be able to smoke. I want lots and lots of room. I want lots of free stuff. This is very, very important to me. I want free food. I want free booze, basically. And I want to watch movies for free as well. So essentially, when I talk about saving money, I'm talking about not spending a lot of money and getting all of this stuff for free and having all the luxuries that I want to, that I don't have to pay for. Okay, so that's how I would interpret save money if I was the end user, if I was the passenger of the passenger airline. Okay, let's look at the same need, but this time let's look at it from a different point of view. Let's look at this from the point of view of the operator, for example. So remember, the operator stakeholders, they're the roles of the people, the things, the organisational units that are actually helping to run the system. So actually it might be, when I'm talking about saving money as the operator, to me, I interpret that as saying, well, let's provide online check-in, because that means we don't have to do as much work when you get to the airport. Let's get people to print off their tickets at home. That way, we don't need as many printing machines. We don't need the consumables, the paper, the ink, and so on that we would if everybody turned up at the airport and did it. And actually, it's going to help us optimize our service because people would have done half of the process before they arrive. We won't need to employ as many people. We won't need to rent as much space from the airport as we would traditionally. So overall, that's going to save us money. The point here is we've got the same initial statement here, which is to save money, but actually from the user's point of view, from the user context, it's got a completely and utterly different meaning, a different interpretation than if we look at it from the operator context, from the operator point of view. And that's what we mean by context here. If we look at it from different points of view, it can take on very, very different meanings. Okay, let's look at another context on here. Let's just complete the left-hand side of our stakeholder view. Let's look at the sponsor context. So here again, we've got another very, very different interpretation. So imagine if I'm the person who's putting up all the money for the passenger airline. I've still got this need here of saving money, okay? But from my point of view, what makes this a use case now is the interpretation of this from my point of view as the sponsor is I want to charge for goods, and actually I want to squeeze in as many people as possible, as many passengers on the airline as possible. I'm constrained in that I can't just, stack people up like sheep in the back of a lorry, because I've got to comply with standards. So this is where things like standards will come in. But actually, I want to charge for goods and I want to optimize space. So again, this is a completely different interpretation of the same basic needs statement, which was to save money, compared to the operator and compared to my original need here. But this is even more interesting because this time, when we compare one context, the sponsor, to another context, the user that we can see here, what we notice is my interpretation says, actually, get lots of free stuff, have free food, have free drink, watch free movies, have lots of room. When I look at the sponsor's interpretation, it's actually not only different, it's conflicting with my interpretation. It's conflicting with my point of view. Excuse me. It's conflicting with my point of view. So this is what we've got to be very wary of, is not only might different stakeholders have different interpretations of things, but also they might have conflicting interpretations of things. Okay. It becomes even more complex because what we find is these different contexts interact with another. So for example, here, we know that the sponsor context, the user has some sort of interest there going across this line here to save money. What that tells us is that if I look at the user context, we should see that same line on there. And here it is from the sponsor, this time to save money. It allows us to identify use cases that are related to one another. Now, this is an obvious one because the use cases have the same name. But we can see by the breakdown of the use case, they might have the same name, but it's a completely and utterly different meaning that they have there. So it's not just important to understand the different contexts, but it's also important to relate these different contexts together. So again, if we go back to the user one, there's one here, I want to be able to smoke. Now you might say, well, does the sponsor want me to be able to smoke? Your initial reaction might be, well, no, but actually, if the sponsor could charge me to smoke, the sponsor would charge me to smoke. Anybody that's ever flown on some of the budget airlines, I've actually seen this where they've been selling things like e-cigarettes and so on. So actually, both the sponsor and the user, it's not out of the question for them both to want to be able to smoke, but there's a big change that comes in. There's a big difference that comes in here because this stakeholder here, the standards, has a standard that says you cannot smoke. It is illegal to smoke on the airlines. So actually, in order to comply with this standard, which is constraining the sponsor, people aren't allowed to smoke. So what we also have to bear in mind is that sometimes different contexts will have different weightings. They'll have different levels of priority, if you like, and they can override other use cases in this case, or other contexts. So this is why it's even more important to understand, yes, each individual context, but then also to relate them together. When we look at things visually, when we model things using some sort of notation, it really helps us identify these relationships here, and therefore it allows us to identify the relationships, the links between the different contexts. You could do all of this with text, of course, but if you remember, when we spoke about complexity, one of the things that we need to do is think about not just the elements, but the relationships between them. And this is where the complexity will often manifest itself, is on the relationships between things. So yes, it's understanding the interpretation of the different need, but it's the different relationships that we see in here, both within the need itself, but also between different needs. In this case, the use cases that allow us to interpret the needs in different ways. So we should be able to put all these different contexts and, if you like, stick them together. And that this is crucial when it comes to understanding. So let's look at another example. We've been focusing on stakeholders to begin with, but let's so this is just a summary of what we've just said. So when we relate the different use cases together, some are similar and compatible, some are completely different, some are conflicting, and some will overrule others. And it's essential that we can relate these things together. Let's focus on the system now. So previously we looked at the stakeholders and the different contexts, but also we have this idea of a system context that helps us understand the need for the system. We can think of a system as being made up of a number of system elements, and these system elements interact with one another. So we can think of a system as a set of interacting system elements. Okay, let's define this in a bit more detail. So here we've got our stakeholder coming in again. So this is exactly as we saw on one of the previous slides. Stakeholders have an interest in our system, and all we've done on this one, we said actually let's identify what these different levels of system element are. Let's identify what these different levels of system hierarchy are. Okay, so let's look at the same. Let's take a need statement again, and now let's look at it from these different points of view. But this time, rather than stakeholders, let's look at the context. Let's look at the point of view based on where we live in the system hierarchy. So the one we're going to look at, the need we're going to look at, is to be efficient. Okay. Now let's consider the system level. So you imagine this might be, for example, the system level there. We might be talking about an aircraft. Being efficient, when we think in the context of an aircraft, it might be something like, can we achieve so many miles per tank of fuel? Okay, so what distance can we cover before refueling, before recharging, or whatever it's going to be. So actually you might see that this use case here is applying to that level, and that's what we mean by be efficient. If we drop down a level, and let's say we're looking at the engine this time, so we're looking at a subsystem, and let's say that one of the subsystems we're going to look at is the engine, and we say, well, what does be efficient mean from the point of view, from the context of the engine? Well, this might mean, can we achieve a particular power throughput for something with particular performance criteria on it? So rather than so many miles per tank that we saw up here, when we're at this level, it takes on a different meaning again, and this time it's to do with the power throughput. Okay. We might be looking at something like, so we go down to the assembly level, we might be looking at the, a particular turbine, for example. What do we mean by being efficient at this level? It might be something like achieving so many revolutions per second in a particular way. So that might be using different algorithms or whatever it's going to be in our software control. But again, we have a different interpretation of the same need statement, being efficient, because the context have changed, because we're looking at it at a different level in our system hierarchy. When we write down at the component level, this might be representing an individual blade in our turbine, the piece of metal, if you like. And being efficient there might come down to the choice of material, use kryptonite or whatever it's going to be. So what we're seeing here is we can take the same need and the same principle of context applies. Okay, we're applying it at different levels, and therefore it's taking on different meanings. So the different contexts are giving us different meanings.
John, before you move on, we've got a question come through.
Okay.
Whether you want to read it in the chat or I'll read it out.
Right, if I find my mouse, I might be able to even read the chat. That is my mouse gone. Right, I can't see the question. What is the question, Simon?
Okay, so if I end up with contrasting / opposite needs for use case or use cases,
yeah,
I should then always weight them based on the main context and analyze mainly those ?
Right, so if you're looking at things from different contexts and there are conflicts, so what was it? Should you always do them based on them? Did you say the main context?
Yeah, yeah. I mean, it's certainly something I know we talk about on some of our courses, that in theory, you can weight the various
Yeah.
stakeholders or system elements, and some are more important than others. And so, yes, they may trump other needs. But I'd hate to say,
it's not always.
That's an always. I mean, yes, it can give you some guidance. It can certainly give you some guidance as to which ones to look at first. And
no, I think with some of them you can make that distinction. So I think the example of things like legislation, that it can be done there. Where it's not as clear, and there might need to be some sort of compromise. Again, the point I think he raised in the question is about, well, you need to analyse them. So I'll just say a couple of words on, if you like, the next step. What do we do once we've got these use cases? How do we make sure we understand them, and how do we get rid of these conflicts? Well, one thing that we have to remember is that when we look at use cases, so any of the use cases on here, so any use case, basically, we need to validate that. We need to validate our use cases. Okay. The way that we do that when we're modeling is we consider scenarios. Okay. And when we're doing this kind of modeling, there's two main ways that we can do the scenarios. We can talk about, for example, formal or performance type scenarios. And we can talk about semi-formal, or if you like, operational. Oh, I've gone off the edge. Type scenarios. In modeling terms, what we can do with that, if we have something like an operational scenario, this would typically be taking a specific use case. I'm just going to put system in the middle there, considering the system and considering the interactions between the various stakeholders using something like a sequence diagram. And what it allows us to do is to say, well, actually, we got an outcome here. And what particular sequence of events might lead us to that outcome? Okay, so that might be one particular scenario. And then we can say things about, well, actually, what if, and this is key to scenarios, what if actually this interaction here didn't happen and something like that happens? So scenarios allow us to explore different what ifs. We use scenarios to validate the use cases, but also another use for the scenarios is just to allow us to actually understand in a very fine level of detail exactly what do we mean by that particular use case and what happens if that use case fails. Okay, so for example, what would happen here if I can have free food and free drink but not watch free movies? Would I still go on the airline? Do I automatically not not use this system, not use this particular service because I failed on one of my use cases? So can I weight the different use cases in that way? What's more important to me? So we can look at things like scenarios and even do things like say, well, how many scenarios are there for particular use cases? And how often do the different stakeholders interact with them? So we've got a use case here and we find that the user has got 100 different interactions with that particular, when we're considering that use case. Whereas this one over here, we've only got 2 interactions from the user. When we're looking at our scenarios over here, that will tell me that this one here has probably got a higher priority because it occurs in more scenarios than the one that we've got over here. So there are different techniques we can use to do that. And the same way, if we look at things like performance type scenarios, we'll be looking at things like parametrics there, setting up parametric networks, defining parametric constraints, and so on. So the basic rule of thumb is if it's this happens, then this happens, then this happens, that's performance, that's operational, something like a sequence diagram. If it involves numbers, then it's usually something like a parametric diagram, and it's something where we're reasoning about parameters on the system and doing different what ifs then. So when it comes to identifying the priority of different use cases and different stakeholders for that matter, yes, some of them we can do because some of them will be clear, like legislation. Others won't be as clear cut. So what's more important, something a user wants or something an operator wants? Because if we don't satisfy the operator, we can't run the system. But then if we don't satisfy the user, we can't sell tickets. This is where this other type of analysis comes in, where we start to look at scenario modeling, and we can do things like considering the number of different scenarios, the number of times each particular stakeholder occurs on different scenarios and so on, and we can make a judgment call based on that.
John, we've got another question from Matt.
Yeah.
Are have a good service and have lots of room really use cases, or more simply customer needs? It would be difficult to create an activity or sequence diagram for either of these.
Yes, but what we could do on there, I mean, that's a good example of the difference between the performance and the operational type. You're right, Matt. It would be difficult, but not impossible, to create a sequence diagram for one of those. But what we can do, for example, is we can actually define some measures here to say, well, what do I mean by lots of room? If it was somebody like me, it might be, you might do it based on height or leg length, for example. How much leg room do I have? So that might be part of your definition. So your scenario there, you're right, you wouldn't do a sequence diagram for that one, but you might set up some parametric networks for that one. The same with having a good service. How do you quantify having a good service? These are, how often do people come and offer you food? How often do they come and ask if you're okay? Are they giving you blindfolds to sleep in, and all these sorts of things? So again, you've got to remember, this is why we have these two different types of scenario here. The performance ones tend to be the constraint type scenarios, so things like non-functional use cases, things like constraint use cases or non-functional use cases, things that are going to involve numbers. So that's performance, parametric networks, things that involve sequences. I want this to happen, then this happen, and as a result, this happens. There are operational scenarios, and they're the ones that we use with sequence diagrams. Okay.
So it's like, needs such as, entertain audience, let's say, if you're doing some kind of show, or be exciting, and how do you measure that? You can't do a sequence diagram for it, but you can do, surveys and get measures of how the audience, for example, react to a show to show whether your show is exciting or not. So, not everything has to be as, if you're going to say hard systems engineering as sequence diagrams, and sometimes, the soft system stuff has to be used.
And I think it comes down to, because you've got to remember that one of the big uses for our scenarios is validating something. And when we validate something, we're demonstrating to the relevant stakeholder that we satisfied the original need. And what we've got to be able to, another way to look at that is we've got to quantify it in some way so that we can make that stakeholder. We've got to measure it in some way. And the measurement might be saying, look, we do these things and we achieve this particular outcome. But the measurement might also be, we have a particular level, as you say, Si, we have a particular level of satisfaction. So let's take an example. Let's take today, for example. So the way that Simon and I look at this when we do our sort of post-talk analysis, how do we measure if it's been successful or not? Well, some of the measures that we're not going to do a sequence diagram, but some of the measures that we will apply will be, how many people did we have? How many questions did we have? How many comments did we have at the end where people said thank you and that sort of thing? How many people joined and then left? So we'll look at those sorts of measures on them. So again, what we're looking to quantify there, as Simon said, it's not the hard, here's a sequence of things that happens, because the sequence for delivering these talks is quite straightforward. We log on, we send out the invites, we talk for 45 minutes, and then we all go away again. But actually what makes it successful is applying the non-functional measures to that, the non-functional scenarios, which is how well did it go? What was the reaction that we got? And you're quite right, Matt, we can't really measure those in sequence diagrams, but we can measure them for things like parametrics. Okay.
Just to remind you, John, you've got 4 minutes now, but Stephen Powley says it's also important to think about misuse cases.
Yeah, absolutely.
Particularly with increasingly connected systems and things like cybersecurity and threats.
One of the talks that we've actually got in mind is looking at it in more detail at this whole point of use cases and validation of use cases, and a large part of that is the misuse cases. Is trying to break the system. How do you design a system for failure? How do you design a system that's going to be hacked? And again, if you think about security, and this is something that I know that Simon, you and Stephen, we've spoken about these things together. It's the cornerstone of things like security and safety is context again, because what you've got to think about with security, let's say security of a car, you've got to put yourself, you've got to look at it from the point of view of somebody who either wants to steal that car or damage that car, or you know, take that car apart, or whatever it's going to be. So context is key again when we're looking at these kinds of things. Okay. So let's progress then. So where were we? So again, we're looking at things not just from the different stakeholder roles that we saw there that give us one type of context, but also we're looking at things. I don't know what happened there. We're looking at things at different levels of abstraction, at different levels in our hierarchy. So when we talk about context, it impacts on just about everything in MBSE. We gave an example here looking at our needs modelling, but also our analysis, our basic understanding of the problem. It's going to help us with that as well, looking at things from the different points of view. Obviously, solving the problem with our design. How does the system work? How do we, when we're in utilisation and support, the whole operational side of things. Verification and validation, we've touched on very, very briefly. Everything that we do in MBSE, everything associated with the M, the model, it's got to be dependent on the context. The context is so important whenever we're doing the modelling. We must understand the context in order to understand the system. You need to bear in mind that we always say, you know, people say, well, when do you apply modelling? As we said earlier, we're applying MBSE as a whole across the entire life cycle. We can apply modelling across the whole life cycle, because basically another way to think about modelling is you can apply modelling whenever you need to understand something. So what you've got to ask yourself is, well, at what points in the life cycle do you need to understand things? The obvious answer to that is, well, at every point throughout the life cycle. Therefore, we can use modelling to help us to understand the system at any point in the life cycle. One of the basic rules of thumb that we always apply, and you know, we've been saying this for decades now, Simon, haven't we, that we always stand by, is that basically if you can model something, you understand it. If you're struggling to model something or you can't model it, you don't understand it. And that can tell you a lot about the source information. If someone gives you, for example, a set of requirements, a standard, a specification, anything, and you start to model it, and if the model falls out very easily, if it's a relatively simple process of creating the model, that tells you that the source information is well understood and well presented. If you take that same information and it's difficult to model, and there's lots of ambiguity and there's lots of questions, it tells you that that source information is not very well understood. And this is very, very important, and it's a very important test that we apply all the time. People say, well, my requirement, I can do text-based requirements perfectly. Some people can, but a simple test to do that, let's use text-based requirements as the example, is to model them. And if the model falls out really easily and it's complete as far as you can see, and it's got the different context in, yes, they produce brilliant text-based requirements, and some people can do that. However, if you start to identify ambiguity and things that are missing and conflicts because of different points of view, then it's increasing your level of understanding, and you're getting the benefit from the modelling. Okay. So, oh dear, I'll tell you what I've done now. I've got the wrong summary slide. It's like going back 2 weeks, isn't it? So ignore that slide. So summary then. There we go. Look at that. This is systems engineering in practice. So context. We need to identify the context. We need to look at different contexts and interpret. And that's what gives us our use cases. Okay, and above all, understanding depends on context. Okay, there we go. Summary slide on the fly, not terribly legible, but there we go. So I think that pretty much concludes what we're going to talk about formally today. just to wrap up with our usual slides, buy all of our books, of course. Christmas is never too far away to do that sort of thing. And also, finally, just to add, if I can get my last slide up, we've got our public training courses coming up in the next few weeks. We'll have 3 events every Thursday. So we announce a topic usually on a Monday on our LinkedIn page. So please join us on LinkedIn to do that. We've got the model-based social event that will be taking place in about 15 minutes immediately afterwards. So Simon, any initial suggestions for topics on that? We usually will talk about what we did in the presentation, but anything else that people have. So
yeah,
Simon,
yes, I mean, certainly, if anybody have got any points they want to bring up, that's fine. But something that Stephen and I are working on for ATEC, if our paper gets accepted, ties in directly with the context around system, subsystem, components, that kind of thing. Looking at how we can, in a model, show that different parts of a model can be thought of at different levels in different contexts. So we could give a sort of heads up on some of our thinking around that.
Great, good stuff. And if you do get your paper in and it's very successful, you might win the Vicky Anderson Best Paper Award, which we're now going to call it from this point forward.
Yeah, but only if I can win everything else as well.
Yeah.
I want at least a free vacuum cleaner and
yeah. That's it, Vicky. This is how Vicky's going to fund all her Christmases from this point forward. It's just to win all the prizes. So.
Yeah, absolutely.
If you remember Vicky's family, you're either getting an intelligent vacuum cleaner or an Amazon voucher. Let's face it, from this point forward. Remember, we do our bespoke training as well and all our other bespoke services. Visit our website for more details. Have a look at the Scarecrow's Knob, who at any point look at our online videos as well and our resources. Thanks everybody for joining us, and we'll hopefully see some of you in a few minutes for the model-based social event. Okay.
Cheers. Thanks all.
Thanks.